Companies today face new and growing demands on their data centers, especially when it comes to storage. And the data centers require high performance, scalability, and flexibility to meet those demands, including adapting to ever-changing business needs. And to handle the growing demands on storage, a growing number of platform providers and enterprises are turning to scale-out architecture. What is scale-out architecture? Why is it becoming so important? And how does it integrate into today's virtualized environments? In this webcast, we'll answer these questions and more with two leading experts on scale-out architecture, Gartner Research Vice President Roger Cox and Michael Schnapp, Chief Technical Officer of Infortrend, a leading provider of intelligent RAID-based storage systems.
Scale-out architecture is a new architecture that's come onto the scene in the last 2 or 3 years in the storage space. But it's actually been an architecture that's been quite prevalent for some time in the computing space. So you go back in time and look at history, the architecture and design of all computing systems and storage platforms were what we call a scale-up. In other words, if you wanted to have more capacity or wanted to have more speed, you had to get a faster processor. You had to add more disk drives to the enclosure. Over time, what happened was with the advent of the x86 architecture from Intel and others, what we've seen is ability to paste together, if you will, computing platforms into a grid that you can scale out in order to get increased performance. We've now adopted that in the storage space, where you can put together different pieces of the storage infrastructure, the components themselves, into a scale-out form, thereby increasing performance and capacity in a linear manner. Today, scale-out is an emerging architecture, one that is being increasingly adopted by leading platform companies in the world, and we think by the year 2012 it will become a very predominant form of storage infrastructure for the enterprise. A scale-out architecture brings many benefits to the enterprise today. Consider this. The enterprise has the needs for more than one type of storage platform for its infrastructure. It has needs for entry-level storage systems, mid-range storage systems, as well as what we call large enterprise storage systems. Each one that you go up the stack on is a different product. It has a different management characteristics, a different provisioning characteristics. The components are different. Everything about those three levels of storage infrastructure is different, and as a result, it increases the cost of the storage infrastructure to the enterprise. The scale-out architecture, on the other hand, allows you to start with a small number of nodes in the infrastructure itself. It could be a couple of nodes at a minimum, and be able to scale that up to some n number of nodes in the infrastructure itself, allowing you to reduce your cost, at the same time allowing you to have the same provisioning capabilities, the same root cause analysis software, the same data services software, as well as all of the components being exactly the same. So the primary benefit is really one of reducing cost of the storage infrastructure for the enterprise, which today is one of the key issues that all enterprises face. In a storage infrastructure, the key element that you're after is to reduce the number of assets that you're managing. So without virtualization, what you're faced with is managing several different assets in order to be able to accommodate the capacity requirements of the infrastructure itself. So in its broadest forms, what virtualization allows you to do is to pool all of these discrete assets into a common pool, thereby reducing the difficulty of managing that common pool, and by giving you one pane of glass in order to manage multiple assets. This has become the benefit of virtualized storage in the infrastructure today. So it's very important for the people responsible for implementing a scale-out architecture to understand not only the internal workings of the technology itself, but also the external workings of that technology. So in that respect, it's very important to understand the host interface, which today we should support both fiber channel and iSCSI on the same platform. And on the back side, it should be able to support all of the hard disk drives that are available today, including fiber channel disk drives, as well as the emerging serial attached SCSI disk drives, and of course the high capacity, low cost SATA disk drives. With regards to the internal aspects of a scale-out architecture, it's very important to understand how the product is being provisioned in terms of provisioning the volumes and the LUNs within the storage system itself, that it has adequate snap copy capability, space-efficient snap copy capability for backup and recovery, as well as asynchronous and synchronous remote replication for disaster recovery. So all of these aspects need to be investigated, need to be evaluated, and need to come to a conclusion as to which vendor provides the best scale-out architecture to meet the needs of a particular enterprise environment. I think there are a couple of things that are important with regards to what the enterprise should consider before deploying a scale-out architecture. Number one would be whether or not the enterprise has needs for entry-level storage, mid-range storage, or high-end enterprise storage. If they do have those kind of needs, then a scale architecture would be very, very applicable in that environment because it reduces cost, at the same time simplifies the infrastructure immensely, as we've talked before. The second reason why you'd want to do a scale architecture would be the fact that you have an application that requires a large pool of data. In other words, you want to have a large pool of data under one namespace. And if you do that, then a scale architecture is very, very attractive in that environment and is being widely deployed in that kind of environment today.
Infortrend is a Taiwanese company that was founded in 1993. For more than 15 years, we've been dedicated to designing, developing, manufacturing, and selling intelligent RAID-based storage systems. We have branch offices in the US, UK, Germany, China, Japan, and this year, Infortrend will release a new enterprise storage solution called the ESVA series. ESVA stands for Enterprise Scalable Virtualized Architecture. It is a full-featured storage virtualization platform that provides both capacity and performance scalability. In addition to providing capacity migration to allow for addition or removal of storage capacity from virtual pools and thin provisioning to enhance storage capacity utilization, it also implements patented data load distribution technology that allows performance to scale out linearly with addition of new storage systems to virtual pools. In addition, it provides complete snapshot and replication functionality to meet the most demanding backup and disaster recovery requirements. Overall, ESVA serves to enhance return of investment, simplify storage scaling, and maximize productivity. Well, you know, low storage utilization is always a prominent concern in the IT environment. With direct attached storage, so-called DAS, the utilization is about 30%. If DAS is consolidated into a storage area network, a so-called SAN, the utilization is still often no more than 50%. The poor capacity utilization is a result of not being able to consolidate capacity that is dispersed amongst different storage systems. As shown here, there is 2 terabytes of free space on one system and 3 terabytes on another system. With traditional storage, the capacity must be presented as 2 different LUNs to the host. Storage virtualization technology eliminates the problem since the storage consolidation that it enables can overcome physical boundaries. As you can see in the virtualized environment, when users introduce a new application, the consolidated 5 terabytes of free space can be easily leveraged by the new application as a virtual data volume. Thin provisioning is a technology that improves utilization by pooling free space and making it available to applications as needed rather than configuring a fixed capacity for each client host. It works by fooling client applications into thinking they have more capacity than has actually been allocated to the application at the time. In the figure presented, 2 virtual volumes are configured in a virtual pool that contains 10 terabytes of actual capacity. The first volume is presented to the client applications as having 20 terabytes, while the second volume is presented to the client applications as having 30. So in this example, a total of 50 terabytes is presented to the applications, while there is only 10 terabytes of actual capacity available. Thin provisioning allows capacity to be dynamically added to a pool as free space gets used up. The addition of capacity is completely transparent to the host. Thin provisioning allows storage utilization to reach levels of 80 to 90%. In addition, management effort is substantially reduced as effort spent on forecasting, planning, pre-allocating, and monitoring individual data volumes is no longer necessary. Well, in a general sense, the concept of scaling out is the nearly linear increase in performance as computing nodes are added. Scale out has been a popular architecture in servers for years, but is a relatively new idea for storage. To achieve scale out with virtualized storage, the ESVA automatically balances workloads on the member storage systems by keeping IOs evenly distributed over the systems, as can be seen in the figure. The problems of performance scaling are similar with those of capacity scaling. When the performance limitation of a single storage system is reached, the traditional way to achieve higher performance is to replace the old system with a new one. Users' scaling choices, however, are limited by what the vendor offers. For example, even if users think they currently need only 2 times better performance, they may have to buy a new system delivering 5 to 6 times better performance because it is the only available next-level upgrade choice. What's worse, the new system they spend much upfront investment on often comes with poorer price performance than the old system. The process of system replacement also involves data migration, and as we have discussed, data migration takes a lot of time and money. Moreover, after the migration is done, the old system will typically be discarded or relegated to secondary applications. It can't be used to contribute to enhancing performance for the primary application. With ESVA, users can enjoy flexible scaling as their needs grow. As shown here, scaling to achieve a performance improvement of several times is as simple as adding new storage systems into the storage pool. It requires no manual data migration and offers excellent price performance. Well, since the ESVA series targets mission-critical applications, it incorporates robust data protection features into its virtualized architecture. The ESVA supports storage-based snapshot and replication, both within and across storage pools. By strategically deploying snapshot images and full data copies, users can enjoy the highest data availability and quick service recovery, whether the problem encountered consists of logical errors, physical errors, or even disasters. Okay, well, there are 3 basic approaches to implementing storage virtualization currently on the market. There's server-based, appliance-based, and storage-based. Server-based storage virtualization is achieved by software running on a server. It requires software installation on each server, and the software must be compatible with a server operating system. This method of implementation results in server overhead and multiple points of management. Appliance-based virtualization is accomplished by either intelligent switch devices or dedicated hardware appliances. It requires users to make additional hardware investment, and the deployment process is quite complicated. The last way to realize storage virtualization is to embed the technology in the storage system itself, and that's also the way ESVA adopts. Virtualized storage resources are available to any host that can access the system. Storage-based virtualization is easy to deploy. With no extra hardware or software, users can enjoy simplified management and data protection. It is an ideal choice to help companies make the most of their storage investment to enhance business competitiveness. Infortrend ESVA is designed for mid-range enterprises and to fulfill their storage requirements for mission-critical applications such as database and email requiring cost-performance investment. Infortrend has established enterprise-class product warranty and services with our worldwide channel partners. Customers can visit Infortrend Global website at www.infortrend.com and contact Infortrend regional offices or channel partners for more information.